Peace to everybody. This is the first photo of a black hole, and as you can see here in the video, is the first black hole photo. As what the hole is real deep, but there's gas around it, so you know what it looks like. In April 2017, scientists used a global network of telescopes to see and capture the first ever picture of a black hole, according to an announcement by researchers at the National Science Foundation Wednesday morning. They captured an image of the supermassive black hole and its shadow at the center of a galaxy known as M87. So they used various telescopes. In other words, it's a whole network of them, so they could see and capture the first ever pictures of a black hole, as you could see. And it was it was by research that announced at National Science Foundation. So, and the black hole was very much captured. This is the first direct visual evidence that black hole exists, the researchers said. In the image, a center dark region is encapsulated by a ring of light that looks brighter on one side. The massive gallery called Messier 87 or M87 is near the Virgo galaxy cluster 55 million light years from Earth. The supermassive black hole has a mass that is 6.5 billion times that of our sun. So it's really a lot more than what the sun is. And of course, the researchers had a central dark region to encapsulate the capitated or whatever by the telescopes that they were using, so they could see things far out in the galaxy. We have seen what we thought was unseeable, said Shepard Dolman, director of the Event Horizon Telescope collaboration. We have seen and taken a picture of a black hole. So yeah, so it was they had a telescope that you could not even believe that it was, so that you could really see really what's going on in the galaxy. As you can see here in the picture is the black hole with the gases around it, and it was captured by the Horizon Telescope, so it's a big telescope. The Event Horizon Telescope collaboration, called EHT, is a global network of telescopes that captured the first ever photograph of a black hole. More than 200 researchers were involved in the project. They have worked for more than a decade to capture this. The project is named for the event horizon, the proposed boundary around a black hole that represents the point of no return where no light or radiation can escape. So now with this black hole, radiation can't escape. The even the light can't escape. So it's like it's all trapped in there to keep it from coming out of the black hole. And it took over 200 researchers to get involved with this project, and that is a lot of people. But I guess the more things that we find out about things in the galaxy, the more we're going to know about stuff. But just for right now, we don't know that much of what's going on out in the galaxies that are millions of years away from the Earth. In their attempt to capture an image of a black hole, scientists combined the power of 8 radio telescopes around the world using very long baseline interferometers Interferometry, according to the European Southern Observatory, which is part of the EHT. This effectively creates a virtual telescope around the same size as the Earth itself. So it's about the same size as Earth. And of course, Earth is not really that big, obviously. Uh, so it is called the third rock from the sun, as you could tell. But they took like 8 radio telescopes to use it to really see what is going on, and it's a very long baseline at that. The telescopes involved in creating the global array included ALMA, APEX, the IRAM 30-meter telescope, the James Clerk Maxwell telescope, the large millimeter telescope, Alfonso Sereno, the sub-millimeter Aries, the sub-millimeter telescope, and the South Pole telescope. So they had all these telescopes that they had to use to see the global area of all these stars and everything, or the black hole. But of course, stuff is trapped in there, like all the dead stars that we never knew about until it was like. And of course, it takes a lot of research to do these galaxies. And as you can see here, here's Dr. Stephen Hawkins, who had passed away, of course, but he knew what was going on in the galaxies and everything else. The observations were a coordinated dance in which was simultaneously pointed our telescopes a carefully planned sequence, said Daniel Marone, associate professor of astronomy at the University of Arizona, to make sure these observations were truly simultaneous so that we could see the same wavefront of light as it landed on each telescope. We used extremely precise atomic clocks at each of the telescopes. So there's I, I guess there is clocks at each of the telescopes. But where are they? But where we do we know if they're at the bottom or at the top? No, we don't know if those clocks are at the bottom or the top of the telescope. So it's kind of hard to tell how or where the times are, and it takes an awful lot of research to, but and it does take a lot of effort and time into it because it's hard work to do these to get the exact readings that you need. The telescope area collected 5,000 trillion bytes of data over 2 weeks, which was precise through supercomputers so that the scientists could retrieve the images. So yeah, there was a lot of data, or trillion bytes data that was used in over 2 weeks. So, and it's like, holy wow. So yeah, and they needed to, because so they could capture the images that people want to see and what it looks like. Details of the observation was published in a series of 6 research papers published in the Astrophysical Journal Letters. So yeah, it was published, and it took 6 research papers to put it in that journal. Black holes are made up of huge amounts of matter squeezed into a small area, according to NASA, creating a massive gravitational field which draws in everything around it, including light. They also have a way of superheating the material around them and warping space-time. Material accumulates around black holes is heated to billions of degrees and reaches nearly the speed of light. Light bends around the gravity of the black hole, which creates the photon ring seen in the image. So yeah, wow, that's a lot of reaching to do. It the where the light goes around and where does it end? You'd never know where it ends. So there's a lot. So black holes made up of millions of squeezed small areas. So it's pretty small or big or whichever one you want to put it. And they have superheating the um, that you don't want to really want to touch on too much because then the scientists will wonder what is going on in that. But they know what they're doing. They do. It just takes a lot of effort into it. The imaging methods used to capture the photo reveal that the supermassive black hole has a ring-like structure and a shadow, which is represented by a dark central region. And as you can see here, here's what it looks like. And it's a lot of light. Right down in the middle is the black hole, but you really can't see what's on the other side of it because you're only getting this, what you see in the photos. A lot of lights. I guess there's dead stars somewhere in here and everything else. If measured in a bright region like a disk of glowing gas, we expect a black hole to create a dark region similar to a shadow, something predicted by Einstein's general relativity that we've never seen before, said Neil Falkett, chair of the EHT Science Council. The shadow caused by the gravitational bending and capture of light by the event horizon reveals a lot about the nature of these fascinating objects and allowed us to measure the enormous mass of M87's black hole. So yes, they were allowed to measure it, get an idea of how big or how deep it is, and that's what they do. And, and yeah, that's what they do. They measure at a good distance. The visual confirmation of black holes acts as confirmation of Albert Einstein's theory of general relativity. In the theory, Einstein predicted that dense, compact regions of space would have such intense gravity that nothing could escape them. But if heated materials in the form of plasma surrounded by the black hole and emit light, the event horizon could be visible. So it doesn't matter if there's a light or not, but it there's a lot of heated materials in the black hole right now, and of course there it's being turned into plasma. So and it's I don't know. I never really looked at a telescope. I never really did go to a place where they have telescopes where you can look up in the galaxy and that, but you could probably get a good idea of what is out there. Once we were sure we had imaged the shadow, we could compare our observations to extensive computer models that include the physics of warped space, superheated matter, and strong magnetic fields. Many of the features of the observed image match our theological understanding surprisingly well, said Paul T.P. Ho, EHT board member and director of the East Asian Observatory. This makes us confident about the interpretation of our observations, including our estimation of the black hole's mass. So yeah, they compare everything together. They want to see what's what. how's this measured with the other, if they're the same or if something is different, or and of course there's strong magnetic fields that are probably out there in the galaxies. You don't know though. And as you can see here in the picture, this is what it looks like. These are the black holes from the early universe. So you know how and what the idea of it looks like. M87's black hole has an enormous mass, which gave researchers reason to believe it may be the largest viewable black hole from Earth. Relative to other objects, supermassive black holes are actually small. This is why they couldn't be observed before. Black hole size is directly related to mass. The larger the black hole, the larger the shadow, and black holes may seem visible, but the way they interact with the material around them is the giveaway, the researcher said. So yeah, they're mostly small, so I guess it's just not too big of a deal, but that's what they are saying now. They are saying that it's small, so it's just this teeny weeny one that doesn't matter, but it's larger. The black hole is, the larger the shadow will become. So right now, if the black hole is small, that means the shadow is small as well. Black holes have sparked imaginations for decades, said National Science Foundation Director Franz Cordova. They have exotic properties and are mysterious as well. Yet, with more observations like this one, they are yielding their secrets. This is why NSF exists. We enable scientists and engineers to illuminate the unknown, to reveal the subtle and complex majesty of our universe. So yeah, they illuminate the unknown. So you never know what else is out there. But you could only use your imaginations, and that's what the black holes did. They sparked imaginations, and they doing everything they can to, and it's also very mysterious. You just never know what's out there, and it's like, oh, well, this and this, but but they're mostly focusing on that black hole. They're not worried about anything else that's out there right now, and that's how that's how everything is working right now. It's just focus on that black hole and never mind anything else, because they only doing little things here and there at a time. So this is a pretty big deal right here, where the scientists have put out the first photos of the black hole, and that nobody has ever seen before in their life. Leave your comments below. I am out.